Very good morning, dear students. Today in the lesson Substances in Common Use, we are going to study about radioactive substances. Now, what are radioactive substances? Let us try to first understand. So, radioactive substances are those substances with high atomic number, and they have the thorium, rubidium, and radium, uranium, okay, have the property of spontaneously emitting invisible as well as highly penetrating and high energy radiations. So this property of these substances is also called as radioactivity, and the substances which show these radioactivity are called as radioactive substances. The nucleus of such radioactive substances is highly unstable, and because of this unstable nucleus they emit the three different types of radiations. So these radiations are called as alpha, beta and gamma rays. Now let's try to understand who discovered these rays. So introduction to scientist. So let's understand the introduction to scientist Henri Becquerel. So Henri Becquerel was a French scientist, and he was studying uranium compound called as pitchblende. Okay, he had kept some unused photographic plates inside the in a drawer box, in a cardboard box inside the drawer. Okay, and on this box there was a key, and by accidentally he kept happened to leave the uranium compound, that is the pitchblende, on the cardboard box. After a few days he found that there was these photographic plates were cloudy and showed the shape of the key. So as this incident occurred in the dark, Becquerel inferred that the uranium compounds might be emitting from their interiors X-ray like or rays like X-rays, which penetrate the substances. Like here you could see that the card through the photographic plates. Okay, the uranium could penetrate, and because of this penetration there was the shape of the key on the photographic plate. So from this he inferred that these rays are like the X-rays which can penetrate through certain substances, and later on he called these rays as the Becquerel rays. He called these rays as the Becquerel rays. Later on, after few days, even Madame Curie found or discovered similar properties in the compounds of the thorium. Then Ernest Rutherford in the year 1871 to 1937, who was a scientist from New Zealand, studied under the guidance of J.J. Thomson, okay, at the Cavendish Laboratory at Cambridge and McGill University, Canada. He showed that if the nitrogen atoms are bombarded with the alpha particles, they can be split into the unstable elements like fluorine, okay, and oxygen. Fine. So this experiment ushered in a new era in the field of physics. So this is how the discovery of the different radioactive substances were done. Now let us try to learn about the nature of the radioactive substances or radioactive radiations. In the year 1839, Ernest Rutherford again discovered that the radiations emitted by radium were of two types, and he called them as alpha and beta radiations, whereas Willard discovered the third type of radiation called as gamma radiations. Okay, so in the year 1902, Rutherford and Willard studied the radiation emitted by radioactive substances, and for this purpose the rays were allowed to pass through an electric field, and they could see that these rays could be separated into three different types. Okay, so it was found that the radiation was divided into three types. One type of radiation deviated towards the negatively charged plate, and the other type of radiation deviated towards the positively charged, and the third one did not show any Deviation. So the one which could deviate towards a negatively charged plate were called as alpha particles, whereas those which deviated towards the positively charged plate were called as beta rays, and the one which did not show any deviation were called as the gamma rays. Okay, so these three rays were discovered by Willard and Ernest Rutherford. Fine. Now let us try to understand what are the different characteristics of these radiations, that is alpha, beta and gamma radiations. Now let us try to understand what are the characteristics of these radiations, that is alpha, beta and gamma radiations. You have learnt just now that alpha rays, since they are deviating towards the negatively charged particles, they can be called as the positively charged. Okay, whereas the beta rays are deviating towards a positive, that means they are negatively charged. Whereas gamma rays do not show any deviation, that means they do not carry any charge. So let us try to understand what are the different characteristics of these alpha, beta and gamma rays. Okay, so first one is the nature. How is the nature of this? Alpha, beta and gamma rays. Alpha rays are positively charged helium particles, whereas the beta rays are electrons which are negatively charged, whereas the gamma rays are nothing but the electromagnetic waves or electromagnetic radiation, since they do not carry any charge. Fine. So this is regarding the nature. Next one is the mass, that means how much mass each one of them have. Mass, since alpha rays are helium nuclei, its mass is around 4.0028 unified atomic mass. You have learnt about unified atomic mass in the previous term. Okay, it is also called as Daltons. Fine. So it has, since it's a helium nuclei, it has more mass as compared to that of the beta rays. Beta rays are nothing but the electrons, and therefore beta rays have lesser mass, that is around 0.000548 units, whereas gamma rays do not have any mass. Fine. So now next thing is about the charge. Charge of alpha rays is +2 because helium is H2 plus, He2 plus, and whereas the charge of the electrons is -1, whereas the gamma rays, since they are electrically neutral, they do not carry any charge. Then the velocity, how fast they are going, how fast they can penetrate, how fast they can travel. You have learned about the speed of the light. You know the speed of the light is around 3 lakh kilometers per second. Okay, so how much is the speed in comparison with the speed of light of all these rays, we will come to know right now. Now if you see alpha rays are around 1/5 to 120 times the velocity of the light. So velocity of the light is 3 lakh. So if you calculate by 1/5 of the velocity of the light, that is 3 lakh kilometers, it comes to around 60,000. So can you imagine that the alpha rays can travel at a velocity of around 60,000 kilometers per second? So fast alpha rays. Comparative to the alpha rays, beta rays are much more faster as compared to that of the alpha rays. They are around 9/10 times or 1/5 times. So 60,000 to 9-10 times. That means if you go to see, it will be almost like around more than 2.7 or something like that. It will be 2.7 lakh kilometers per second. From 60,000 kilometers to 2.7 lakh kilometers per second is the speed of the beta rays. That means beta rays are much more faster as compared to that of the alpha rays, whereas the gamma rays are very fast. That means they are at the speed of around 3 lakh kilometers. That means at the same speed as that of the light. Okay, next is deviation in the electric field. Now electric field, you know that there are two oppositely charged plates which are kept here. That means it is a electrical field, which is positively charged plate is there, negatively charged plate is also there, and you have seen that alpha rays being positively charged, they deviate towards a negatively charged plate, whereas the beta rays which are negative, they are deviating towards a positively charged plate, whereas the gamma ray shows no deviation since it does not carry any charge and therefore no deflection. Now how much is the penetrating power? Now you see that alpha rays has around 1/20th times to 1/5 times. That means 1/20th, if you calculate, it will be around 15,000 to 1/5 will be 60,000. So 15,000 kilometers to 60,000 kilometers is the speed of, or is the velocity of alpha ray. So how much penetrating? Accordingly it will have penetration. Since it is less, it has lesser velocities compared to that of the beta rays, it can penetrate only up to the aluminum sheet of up to a thickness of less than 0.02 millimeters, very less. So you can see a millimeter, if you see in the ruler, is very less as compared to that of the centimeter, or tenth part of a centimeter is called as a millimeter, and 0.02, that means you are still dividing it 100 times. So that much thickness only alpha particles can penetrate, whereas the beta rays can penetrate up to 2 millimeters. That means it is around 100 times, it has more than 100 times the penetration of alpha particles. Okay, whereas the gamma rays, whose velocity is very high, it is up to 3 lakh kilometers, can penetrate 115 centimeter thick lead screen, which has penetrating power almost 10,000 times the penetration power of the alpha particle. So gamma rays have a very high penetrating power. Next is ionization. Ionization means how much they can ionize other substances. So the ionization, since helium is +2 charge, it ionizes very high, whereas that of beta rays is low, and as comparatively the gamma rays, if you compare, it is very low. Then power to produce fluorescence. You might have heard about the fluorescence, phosphorescence, okay, fluorescence colors, right? So let's see about the power of fluorescence. So the power of fluorescence to the power of the alpha rays is very high, whereas the power of fluorescence to produce fluorescence in the case of beta rays is very low, and the power to produce fluorescence in the case of gamma rays is more as compared to that of the beta rays, that is low. So these are some of the characteristic properties of the alpha, beta and gamma rays. We have learnt now what is their nature, how much is the mass, how much is the velocity, deviation in the electric field, penetrating power, ionization power, and power to produce fluorescence. So this is regarding the characteristics of the three radiations. Now let you in your lesson about the uses of radioactive isotopes have been cancelled, but most of the people have misconception that the radioactive substances are used only for making an atom bomb, but it is a wrong conception, or it is a misconception. It can be useful in the various fields like in agriculture, research, scientific research, medicines, etc. Okay, industry. Radioactive has a lot of uses, but it has been cancelled from your syllabus. That is why I am not going to deal with this topic. Now let us learn about what are the hazards of radioactive substances and radiations. Now let us learn about the hazards of the radioactive substances. Now there are various hazards of these radiations or radioactive substances. Let us learn each one of them. Now first thing is the central nervous system is affected by the radioactive radiation. So our brain is affected and the spinal cord is also affected due to the radiations. Hereditary defects are also generated by bombardment of the radiation on the DNA inside the body. So you can see a hereditary defect in that child. Radioactive substances can penetrate our skin and causes diseases like the skin cancer as well as the leukemia, that is nothing but the blood cancer. Then the radioactive pollutants created due to explosion enter the body through the air, and it is very difficult to control them. Then the radioactive pollutants released in the sea enter into the bodies of the fishes, and through them it may enter into the human bodies and can cause bone cancer in the case of human beings. Then the radioactive paint on the watch can also cause cancer. Then the radioactive isotopes like strontium 90 can enter the body through plants, fruits, flowers, cereals, milk, etc., and can cause the disease like the bone cancer and leukemia. Okay, so these are some of the hazards of the hazards of the radioactive substances. Okay, so let's see a peep into the past. There was a Chernobyl disaster on 26th of April 1986, in which wherein one of the graphite greatest disaster, it is called as one of the greatest disaster, which was caused due to radioactive isotope, okay, of the graphite reactor, and this plant got exploded suddenly, okay, at that time, and because of this the radiations came out. This happened on 26th April 1986 and got exploded and came out, radiations came out. So due to this, what happened is radioactive isotopes entered the human body through water, land, and caused certain genetic disorders. Okay, so these genetic disorders due to mutations can cause certain genetic mutations in the baby, and this was carried on further due to you have learnt about the Mendelian principles of heredity. So from one generation it got carried over to the next generation due to inheritance, right? And certain diseases like the thyroid, diseases of the thyroid increased in children as well as in the adults. As a result, the incidence of the throat diseases were greater than in the other places. So this is regarding the hazards of the radioactive substances. So you could see that so many different types of cancer, bone cancer, leukemia, skin cancer, then thyroid cancer can also happen and can be carried due to mutations taken place in the DNA, okay, and from one generation it could be taken to the next generation. So these radioactive substances are very harmful because these radiations not only harm one of the generation, but it can harm the lineage completely of that person, or it will be affecting the whole heredity. Is that clear? So they are very harmful. We also know that we have also seen there are certain uses of it, though it is not dealt now in the detail, but you can go through these uses of the radioactive substances where they are used, because it's very useful information for you. Okay, so this is regarding today's topic, that is radioactive substances. I hope so you have understood. I want you all to read the lesson thoroughly and try to learn about radioactive substances like alpha, beta and gamma rays. What is the nature of these, or what are the characteristics of these, what are the harmful effects of these, who discovered them, how was the discovery, and what are how these alpha, beta and gamma rays were discovered. Okay students, thank you very much. Next time we are going to learn about some chemical substances in our day-to-day life. Till then students, thank you and bye.